Hello, welcome back to another Godot study session. I think for this video, I'm gonna try to do the reading out loud to do the reading out loud, and I'll probably cut that out in the video, so I'll just go over a summary of what the lesson's about, and then we can go straight into the problem they have, just to cut the time, I guess. So yeah, I'm gonna try to do that. I think that might be a good plan. And for today's music playlist, we're going to have in the background, I found this calm Pokemon game music to finish the day. I'm kind of starting my day, or I'm in the middle of it. Went to the dentist. Luckily, the numbing on my upper lip is gone. But I went to the store. I did a lot of nice little errand stuff today. I took care of myself today, which is pretty cool. So now I'm focusing on doing studying. So thank you. Shout out to Bluebird Gaming for this cool Pokemon thing. I hope I don't get copyrighted to the point that it'll cancel it out, but we'll see. That's perfect. Alright, in summary, after reading over this, we talked more about variables, defining it, and I kind of went over just basically why they use var. So var can change, in this case, it can be anything. So it can be an integer, it could be a string, it could be a list, a dictionary. I don't know if they have lists. They probably do. I just haven't seen it yet. But the problem with that I'm worried about is that they brought it up here that you can assign var health to 100, but then you can change the health variable to a string. So it was first an integer, now it's a string, and it runs. It doesn't have an error. And I was talking about how I believe that's why I love data types that let you specify. Because let's say you wanted a string of health, but you forgot to put the quotes to make it a string. The computer would let you know, hey, you said this is a string variable, but you have an integer as the value. You need to change that. And that's what's helpful about being able to specify what kind of data type you're using for a variable, and why it's scary that you can just say variable and it can change into anything if you're not careful. But now they're saying that they're actually, later on, will go into variable types. So that's great. I hope that they have some kind of way I can specify what kind of typing I want for certain variables. But for now, let's see. Define a health variable. In this practice, you'll define your first variable and give it a specific starting value. Define a variable named health with a starting value of 100. You can define... Okay. I don't know if this needs to be in a function. And then we can define var health equals 100. Does it need to be in a function? Uh-oh. What did I... Oh, maybe it doesn't need to be in a function. Maybe I'm overdoing it. Does this? Okay. I was thinking maybe... Wait. What if I did do it in a function and just called it? Hold on. Okay, and then we're gonna call run. Can we do that? Nope. Okay. Just a thought. I thought maybe I could, but no, we cannot. All right. Got it. Continue. All right. So now we're moving on to 9, adding and subtracting. All right, this chapter 9 is adding and subtracting is talking about increments and decrements, how to apply them with variables. So using the plus equals or the minus equals. In this case, we're talking about taking in damage and healing, like if we're in a RPG game. So obviously this shouldn't go over it, but that's, we're just sticking with basic code at the moment. Which of these would increase the health of the robot? You would select health plus this and this one. Yes. Following practices, you'll code the take damage and heal functions so the robot's health can decrease and increase. Learn how to deal damage to entities like our robot. Okay. In our game, the main character has a certain amount of health. When it gets hit, the health should go down by a varying amount of damage. Add to the take damage function so it subtracts the amount to the predefined health variable. The robot starts with 100 and will take 50 damage. Right, so health minus equals 50. That is a lot of damage. Dang, that's like a crit hit. Sheesh. Oh, subtract amount from health. Oh, my bad. It's supposed to be... It's supposed to be mount. My bad. I did not see that parameter. Oopsie daisies. Alright. It's time to heal the robot up to full health. Write a function called heal. This is super broken. That takes in an amount. And then health plus equal. Amount. Cool. Yay! Cool animation. Continue. Alright, lesson 10, the game loop. Wait. I'm so sorry. I read that and then I didn't read it at the same time. Okay, so in summary, we're learning loops. This is their set of loops. So Python has like loop, like for blank and blank, or while, like for loops and while loops. So this is kind of a quote unquote loop is underscore process. So it seems that's what we're working with in learning about delta being the parameter. And it seems like it's conventional for programmers in Godot to underscore this, to separate it as a, like, this is how maybe you declare this is a loop. Interesting. Okay. You got it. Alright, so now we're going to learn these loops. Make the robot rotate slowly by adding to the underscore process function. Okay, rotate. We are basically just doing what they showed in the example, but, oh, whoops. My bad. That should be good. I wonder, should I just like, I feel like these lessons have been pretty short, so maybe it's not too bad to have, maybe I'll cut any of the moments where I'm just not doing anything or I'm saying nonsense. But for the most part, I think I'm doing pretty well. I thought I'd be stuck on these for like 20 minutes each, but I'm actually hitting 18 right now, so that's good. Make the robot move in a large circle slowly by rotating it and simultaneously moving it along its x direction. To do this, add the rotate and move local x functions to process. So you want me to rotate, and you want me to use move local x. And you want to rotate what we've been doing. Okay. And then we want to do it 5 pixels a frame. Whoa! There you go. Wait, is it continuing to move or? Interesting. Well, it's not moving anymore. I wonder if they put a limit so it didn't go out of space. I don't know. Time delta, lesson 11. We've seen how we can use our character's process function to make it move continuously. Yes, we have. But it's not just our character that has a process function. Almost everything in the game has a process function. Dozens of times per second, Godot runs every process function in the game to update the game world. After that, it displays an image of the game world on the screen. We call that image a frame. Oh, Godot then moves on to calculating the next frame. As this happens dozens of times per second, you get the illusion of movement. This is similar to how traditional animation works. Oh, we did do a animation thing earlier, and I was learning framing in Clip Studio Paint, and that I only could have, what, 20-something frames? That was such a sad realization. You may have heard of frames per second, FPS. Games often run at 60 frames per second. It means that everything in the game updates 60 times each second. The number varies while playing depending on the game and the device it runs on. On powerful computers, you may get frame rates in the hundreds or thousands of frames per second. Let's look at the process function in more detail. What parameter does the process function take in? It takes in delta. Frames take varying amounts of time to calculate. Depending on the game, the computer, and what the game engine needs to calculate, frames take more or less time to display. There will always be milliseconds variations from frame to frame. That is why the process function receives a delta parameter. Delta represents a time difference. It's the time passed since the previous frame in seconds. We can use it to ensure that the changes between frames don't make the game's behavior unreliable. This is because different computers run differently, so a fast computer will have more frames per second than a slow computer. If we ignore delta, the game experience will vary depending on the computer. Delta helps to make the game experience consistent for everyone. So delta is basically what's balancing the computer's running time. So say someone does have a powerful computer, delta will contribute to the power of that computer and give them like 100 frames per second. Versus somebody who has more of a slow computer, or just, it's not She's there, but she ain't like hitting it like the powerful computer. Maybe it's 50, 60 frames per second. Not that 60 frames is bad, but like maybe lower than 60 frames. I don't know. But Delta will align itself for whoever needs it, rather than setting it to a fixed frame rate that maybe not all can take in, or some would be like, this is too slow. You know. Okay, I see. What do we know about Delta? It varies each frame. It's the time it took Godot to complete the previous frame. It values in seconds. All of these. Delta is the time it took Godot to complete the previous frame in seconds. It's very small because frames happen many times a second. It varies each frame because Godot needs to process more or less each frame. Pause. Okay, play. Multiplying by delta, the delta you get in the process is a time difference in seconds. It will generally be a tiny decimal number. To apply delta, you need to multiply your speed values by it. Oh no, not math. Oh no. Wait, really? Oh god. So delta is just aligning to your computer's time of handling frames per second. Okay. To complete the previous frame in second. Yes. So rotate 3 times delta. So 3 times the amount of frames your computer can take per second. Multiplying by delta, you make motion time dependent rather than frame dependent. Okay, that's essential to make your game consistent and fair. Why do we use the number 3.0? At the top of the lesson, we made a robot rotate a fixed amount every 0.05 radians. In the example above, we now multiply the argument by very small delta value, a value way below 1.0. It makes the robot turn at a constant speed over time. However, multiplying by a number below 1.0 like delta makes the result smaller. To compensate for that and make the robot turn fast enough, we use a larger number than before, 3.0 instead of 0.05. Those numbers have 2 different units. 0.05 is an angle in radians, while 3.0 is an angular speed in radians per second. When you multiply a speed by a time delta, it gives you an angle. Oh god. Speed, time, make an angle. When you say angle, I think of a circle, so like 0.05 radians. I think like that. But yeah, it's an angle in radians. Well, it's an angular speed. How fast it gets to do that angular angle. Cover from one part of the angle to... Is that what we're talking about? When you multiply a speed by a time delta, it gives you an angle. So how much speed it takes to get... How much speed you have to make in order to make the time to cover that radian angle. Do you get what I mean? So like, if it takes 2 seconds, the speed would be whatever the speed is. If it takes 2 seconds to get to a certain angle, then you calculate the speed of what the speed is to make it 2 seconds to get to the angle. I am picking up what you're putting down. I just don't like math. Why the time between frames matters. The time it takes to display a new frame varies. If you don't take that time into account in your code, your game will have gameplay issues and bugs. Godot provides that time to the process function through the delta parameter. In the example below, the top robot moves using delta. As a result, it moves at a fixed speed. The bottom robot moves over a constant distance every frame without taking delta into account. It will move faster or slower than the top robot on your computer. The bottom robot will move differently for everyone. Is it? Oh. Oh my gosh, is it because it's moving slower that like my computer is not as powerful? That's so sad. Interesting. What does that say about my computer? Oh no. I don't know. Multiplying time-sensitive values by delta makes them time-dependent. Oh wait, no, with delta that's like by my frames, what my computer can handle, and then a constant distance what it's set to. Okay, so my computer's good at it. We're fine, we're fine, we're fine. Multiplying time-sensitive values by delta makes them time-dependent rather than frame-dependent. Thanks to that, we get reliable movement over time. Without delta, frame times vary from computer to computer and during gameplay. Because of that, the movement will differ for every player, making the game inconsistent and messy. What does this mean? Rotation speed times delta. You're gonna find the angle? Oh god. Wait. We're subtracting delta from rotation speed. We're dividing delta by rotation speed. We're multiplying rotation speed by delta. Oh. I thought this was a trick question. Why did I think this was... I'm so dumb. I thought I was gonna say like, oh, you're trying to find the angle or something. I'm sorry. I'm overthinking. This is me overthinking. Let's not overthink. Okay. I just don't like math, but I have to be a math girly. I have to be a woman in STEM. If I want to do this, I have to. Come on, we got this. Ugh, we got this. Okay. At the moment, the rotation of the robot is frame dependent, and add delta to make the rotational speed time dependent. Okay. The robot should rotate 2 radians per second. So at the moment, the rotation of the robot is frame dependent. Add delta to make the rotational speed time dependent. So you're saying... Is that what you meant? Or am I wrong? Oh, okay. So delta 2 times with the frame radians. I think I'm still a little... The robot should rotate 2 radians per second. But we're saying we want it to rotate via delta. Because delta... Someone else's 2 is different from another person else. Someone else's 2 radians is different than another person's 2 radians. So we have to multiply it by delta to account for everybody's 2 radians. Okay. Alright. I'm understanding slowly. Okay. In this practice, make the robot move in a smooth circle using delta. To get this movement, the robot should rotate 2 radians per second and move 100 pixels per second towards clockwise. Please write... Okay, I'm so sorry. Someone's texting on the side. I need to close it out because I need to focus. In this practice, make the robot move in a smooth circle using delta. To get this movement, the robot should rotate 2 radians per second and move 100 pixels per second towards clockwise. Okay, that's the move local, right? So we have a rotate, move local x. And we want these by delta. So 2 times delta. And then 100 times delta. These are the values in the parentheses when calling the functions. If you define extra variables, you will not be able to check your practice. Is it doing it? I think so. Nice. It did move, so... Alright, cool. Okay, sorry. In this lesson for 12, we'll make our code easier to follow and understand at a glance. Take a look at this example. Func process delta, rotate 4 times delta. In the above example, what does the number 4 mean? It's how fast the character rotates, it's how far the character moves in pixels, it's how long the rotation takes. Fast or how long? I forgot. I think it's the speed. Yes. Oh, thank God. The code above rotates the character 4 radians per second. 4 radians per second. We can guess what a number represents by looking at the function names, but it's hard to recall what this number does by quickly looking at the code. We've seen how different functions have their own names. Using these names communicates to developers what the functions do. Rotate, move local X, move local Y. As we learned in lesson 8, we can also assign labels to numbers to help us remember what they do. We call these labels variables. A variable is a label for a value we can save, change, and read later. Let's recap how to define a variable. Yes, but you guys said that there are variable types, and I want to know what this variable type is. We improved the first example to make it clear what the number 4 does. Var angular speed equals 4. This variable is defined outside the function. Func process delta, rotate angular speed times delta. Labeling a value makes the code easier for us to read now and in the future. And in the above example, which line defines the angular speed variable? The var. If we define variables outside of functions, we can reuse them in different functions because they're global variables. Because any function can use variables we define outside of them, we call these variables script-wide. Okay, so instead of global variables, they call it script-wide. Alright. I need my notes pad. Here we use the angular speed script-wide variable in both the process function and the set angular speed function. Okay. Process angular speed times delta, set angular speed, new angular speed. Angular speed equals new angular speed. Okay. We can also define variables inside of functions. We align the variable assignment by indenting it to make it part of the function body. Make sure to create the variable before using it. If we define the variable inside of a function, only that function can use it. It's a block variable. Or it's a scope. It's a blocked scope. There you go. Var angular speed equals 4. Rotate angular speed times delta. And you can't use the angular speed because only process can look at it. The angular speed variable only exists inside process because it defined it there. The set angular speed function can't use it. Trying to use it there will result in an error. Here's what this error might look like. Isn't declared. Yes. Where can we define variables? Inside and outside of functions. Variables are also great at grouping values that control how a character behaves. Grouping them in this way allows us to easily change them. Variables to control movement, horizontal speed, jump strength, gravity. Variables for combat, health, health maximum, attack power, defense. Oh, okay. Yeah. In the following practices, we'll define variables and use them with some familiar functions to make our code more readable. Alright, clarifying code using variables, fixing an out of scope error. So we are talking about variables, making them readable. We're talking about what we typically call global variables, like stating variables outside of functions, are now called script-wide in Godot. How those can be used to manipulate in other functions, whereas you can have block-scoped variables, which if you declare them in the function, only that function can see them. So they're basically trying to invite you to do more script-wide variables, especially ones that you want to be able to manipulate in multiple functions. It's kind of like universal Lego pieces. Got it. So let's give the 4 here a label so we know what it does. Create a variable called angular speed outside the process function. Yes. You got it, chief. So angular... Oh wait, whoops, I forgot. You gotta do var angular speed. Did I spell that right? Yeah. Is 4. And then we want to title this angular speed instead. Yay for script-wide variables! Woo! There's something wrong with the code here. Can you see what it is? Run the code and read the error. Correct the code so it works as intended. Okay, before it gives us the error, I want to read it first. So func process delta var angular. Oh, this is what they literally said in the thing. It's because you declared var angular speed inside this function, so set angular speed can't see this variable because it's declared inside. Yeah. So if we want to fix that, simply take that out. Do this. And do that. Yes, yes, indeed. Great. So lesson 13, conditions. In previous lessons, we decreased and increased the character's health, but there was no limit to how much health they could have. Take damage, As a result, the player could increase their character's health indefinitely, which we do not want. Yeah, we talked about this earlier. Uh-oh. What happens to health when we damage our character? Suppose our character has 100 health. What would the value of health be if we called take damage 25 5 times negative 25? I can math that at least. We can use conditions to run actions selectively. Conditions make your code branch into two paths. If the condition is met, the computer will run the corresponding instructions. Otherwise, those instructions will not run at all. Okay, video games and other computer programs are full of conditions. For example, game input largely relies on conditions. If the player presses the button on a gamepad, the character jumps. Yeah. So we're doing if statements. Okay, we're doing the if statements now. Okay, period. When the computer checks a condition, this is called to evaluate a condition. All conditions evaluate to either true or false. Either the player is pressing the button or not. Either the character is touching an enemy or not. In our case, if the health goes over a maximum value, we want to reset it to the maximum. To define a condition, we use the if keyword. If we write a line starting with if, type the condition to evaluate, and end the line with a colon. Oh. That's not a colon. Oh wait, I'm so sorry. That is a colon. I was thinking semicolon from JavaScript. I'm so sorry. That is a colon. It's Python basically, guys. It's Python. Anyways, don't listen to me. Notice the greater than sign. It's greater than. I promise. I haven't taken a math class since senior year of high school, and that was how long ago? 7 years ago? Oh my gosh, that was 7 years ago. Jesus. Because I mean, college, I didn't really. I took like, oh, you know what's so funny? I took a it was a class solely on proofs. Like not geometric proofs, but just like proofs. Like I can't explain it to you, but it was a bunch of if state. It was a lot of like, it was code before code. Philosophy. It was a philosophy class. No, I forgot what it was called, but it was so I didn't expect it to be the class I thought it was, because we were just doing proof statements. That was the test. Was just statements of proofing. It was insane. It wasn't math. It wasn't exactly like literature either. It was just understanding conditions, which actually really benefited me for coding, because like I understood conditional symbols and statements that people would use. I don't know what that class is all about. I forgot what it's called. Now I'm mad that I can't remember it. Yeah, that was nuts. Anyways, back on track. Notice the greater than comparison sign. We read the symbol as greater than. They literally said it right here. Oh my gosh, I'm dumb. I'm not dumb. Sorry. I need to stop that. We've seen how function definitions use a colon at the end of the first line and nest content inside. In GDScript, this syntax is a recurring pattern for all code blocks. The computer knows which instructions belong to the condition because they are indented. Yes. Heal 50. Step. Wait. I'm a little confused. Step? What does step do? Is it just resetting it? That's what reset does. Oh, you're stepping through the function. Oh, if help. Oh, okay. It's helping you through the thingy. Gotcha. If health is greater than 100, bring it back to 100. So that way, you heal 50 and it doesn't go over. Okay. I understand. I'm so sorry. Just give me a minute, guys. Give me a minute. Comparisons. In the above example, we use the greater than syntax to mean greater than. We can compare numbers in other ways too. Greater than means greater than. Less than means less than. Equal means equal to. Not exclamation point equal means not equal to. Here's how we might use these if statements. Yes. What does pass do in the code? It just basically says you can go ahead and handle that. Yeah. Prevents errors in our code when a line cannot be empty. For example, we must have a line of code after a function definition or an if block. When you don't know what to write. Yeah. Okay. When you don't know what to write yet, you can use the pass keyword as a placeholder. And Godot won't give you errors. Which of these statements are true? 1 is not equal to 3. That's not true. 3 is greater than 1. Yeah. 3 is not less than 1. 2 is less than 3. Or else. Ooh, else. Else if. Nice. The if keyword comes with a complementary else keyword. You can write an else block after an if block like so. Func var run var speed equals 120. If speed is less than 100, print you're slow, else print you're fast. I am fast. I am speed. The else block will run whenever the condition above it isn't met. In the following practices, we'll use conditions and improve the way our character's health changes so it has limits. Using comparisons. This series of if statements is all wrong. Change the comparison so each comparison matches the instruction below it. If health is less than 5, health is greater than 5. Right. If 1 is greater than health, 1 is less than health. This is great practice so I know my less thans and greater thans. If health is equal. So remember, this isn't it. This is assigning. Equal is comparing. If health is not equal, exclamation point equal. There you go. Back to my good old Python days. Let's see. We have a heal function that adds an amount to the character's health. Add to the function so the character's health is never greater than 80. Is never greater than 80. Add to the function so the character's... Maybe I'm like, what I had originally thought was if health is greater than 80, then you say health equals 100. Oh, wait. Why don't you just reassign it to 80? Sorry. Oh, bear with me, guys. I may have silly, goofy moments, but I promise I can do it. Preventing health from going below. When the robot takes damage, its health can be negative. We might want to display the health number on screen like in Japanese RPGs. We don't want negative numbers, we want to stop at 0 instead. Calling the function should reduce health by amount. If health goes below 0, set it to 0 again. So, health decrements by the amount. If health is less than 0, set health to 0. See, smarticle particle, slay. Number 14, multiplying. Our robot's health has always been between 0 and 100, but as our robot fights, we want to increase its strength and toughness. When a character levels up, it might deal more damage to enemies, gain new abilities, or in our case, gain more health. We define a level variable to keep track of the level of the robot. It starts at level 1. When the robot has defeated enough enemies, we call the level up function to increment the robot's level. Var level equals 1, func level up, level plus equals 1. As we briefly saw in the last lesson, our robot could have a range of variables that could increase when it levels up. Yes. In this lesson, we'll just focus on increasing the robot's max health. The variable max health is the maximum amount the robot's health can be. We change our heal function to use this variable. Yes, we do. It's a wide script. We could add 5 to the max health every time the robot levels up. Func level up, level plus equals 1, max health plus equals 5. This would increase max health the same amount every time. If we graphed max health, it'd look something like this. Show me. It'd steadily increase. This growth is linear. In our case, we want a feeling of more and more power as the robot levels up. We want a graph like this. Yes, so you have to multiply it, have like some kind of math thingy for it. The growth is exponential. With each level, more max health is added than the previous level up. To get the exponential growth, we multiply the max health by an amount greater than 1 each time the robot levels up. To multiply values together, we use asterisk. What is the value of damage? Var level equals 5, var power equals 3, var damage equals power times level 15. We can multiply by level using, we can use asterisk equals in the same way as decrement and increment. What is the value of damage now? Var damage equals power times level, which is 15, and then 15 times 2 is 30. Let's level up our robot and add exponential growth to max health. Alright. Max health times equals 1.1. In the practices, you'll increase the robot's max health and add a special ability to our robot to make it extra tough at high levels. Interesting. And then by 10%. 10%. You remember the back in the day how they used to do percentages? It's max health times equals. Wait, what? Where's the asterisk? I'm losing it. Oh. 0.10. That's probably not it. It probably was the 1.1, but you know what? Whatever. That's how I remember it back in school. Is that you just take the... Yeah, that's what I thought. So it is 1.1. Wow, so school was wrong? Because it used to be like, oh yeah, you just take the percentage sign and move it down, move it up to decimals, so you're dealing with... Okay, yeah. Okay, I'm just wrong, I guess. Oh my gosh, so you're saying... Okay. Okay. Give me a second. I did. If level... I'm using the right thing. That's greater than. If level is greater than or equal to 2, the amount, the damage taken, right, should be taken by 0.5. Hold on, let me get rid of that if statement. The character appears not to be taking full damage when their level is below 3. Well, that's what this was for. That if that's the case, like if they're not like higher than level 3, then like just take the full amount. That was the whole point. What? Okay. I am so lost. I'm a little confused. So you're saying if the robot's level is greater than 2, reduce the damage amount by 50%. And so I was saying if level is greater than or equal to 2, the amount is going to be multiplied by 0.5, and therefore health decrement by amount. If that's not the case, they're going to skip this and then just do the health amount. So what are we talking about? When their level is below 3. Huh? Do you want me to say 3? No. No. You can't say if the robot's level is greater than 2. Oh my gosh. I said greater than or equal to 2. I thought like, This is what they meant. So that's completely my bad for misreading the directions and misunderstanding what they were trying to sell me. So I should read thoroughly, everybody. 2D vectors. Suppose we want to increase the size of the robot when it levels up. As you may recall, we do this by using the following code. Func level up scale.x scale.y. Yes. Oh my gosh, this is x and y. As we talked about in lesson 7, the scale... Whoa, do you see that? Sorry. As we talked about in lesson 7, the scale variable has two subvariables to it, x and y. This is because scale is a vector 2, which stands for two-dimensional vector. A vector 2 represents 2D coordinates. What are vectors? A vector in physics is a quantity with a magnitude and a direction. For example, a force applied to some object, the velocity, speed, and direction of a character, and so on. We often represent this quantity with an arrow. In Godot, 2D vectors are a common value type named vector 2. Unlike plain numbers, they store two decimal numbers, one for the x-coordinate and one for the y-coordinate. Whee! So far, you've come across two variables in the course which are vectors. Which are they? Scale. Two vectors. Position. Yay! Vectors are great for oh my gosh! Oh my gosh! Vectors are great for games. Vectors are essential in video games. They allow you to represent a character's movement speed and direction, calculate the distance to a target, and more with little code. Take this Turtle AI below. You've probably seen games where enemies move like this. This is done with just 7 lines of pure vector calculation code. This code is a bit too difficult for now, so we'll spare you the details, thank you. But this turtle gives you a glimpse of what 2D vectors can do for you and your game projects. Whee! We scale the robot again, this time by adding it to directly using a vector 2. The following code is the same effect as the previous example. Func level up, scale plus equals vector 2, 0.2, 0.2. Whoa! Okay. Notice how we use... Oh, this is like for like the snake game. You know how you get bigger the more you eat. That's probably... They use vectors to increase your snake when you're eating, gobbling up all the stuff. Notice how we use parentheses and 2 arguments inside the parentheses. Just like other function calls. We call this a constructor function call. You can think of it as a special kind of function that creates a particular type of value. When you use parentheses and 2 arguments inside the parentheses, it is called a constructor function call. It's a special kind of function that creates a particular type of value. The code vector2 constructs a new vector2 value with its x set to 0.2 and its y set to 0.2 respectively. Using vectors to change the position. We can add and subtract vectors to position because it's a vector. If we wanted to move our robot to a new relative position, we would add a vector 2 to its position. I wish I could see the rest of this code, but the end parentheses are... I wonder why it moves to the side. 20, y2. Oh, remember y being a positive moves it downward. But I'm wondering why, like, the x... I guess x is moving it 20 each down. Okay, yeah. How would you move the robot 50 pixels to the left? -50. Position vector 2. Yeah, you don't do position dot... Would you... Okay. I don't think you need to do .x anymore because vector 2 already does that for you. Right? Because you're not moving the y-axis in this. Yeah. This tries to subtract a 2D vector to the subvariable x, which is a decimal number. The value types are incompatible. If you try to do this, you'll get an error. Next we practice is you'll use vectors. Ugh, math. Dang it. My one weakness. How to line a code to the level up function to increase the scale of the body by vector. Okay, well, it literally did show us how to do that, so. Wait. Scale equals a vector 2 0.2 0.2. Is that right? No, I did something wrong. Oh, increase. My bad. There you go. I just assigned it to 0. They're like, ah! My bad. You got it. Okay, resetting size and position using vectors. The robot's level has increased a lot, and so has its size. Let's fix this by resetting the robot's scale and position values. Create a function named resetRobot that sets the scale and position of the robot. The x and y subvariables of the robot's scale need to be 1.0. The robot's position needs to be vector 2, 0, 0. As in the previous practice, make sure to use vectors when dealing with scale and position. So we need to create a function called resetRobot. Okay. That's set to scale and position. So we have the scale. Oops. And we have a position. Can I spell? No. Alright, so the scale needs to have the x and y. To subvariables. Okay, so the subvariables is .x is 1.0 and scale.y is 1.0, and the position has a vector 2 of 0, 0. You got it. Yahoo! Oh, it looks like a scalar position isn't reset using a vector. But isn't that what you wanted subvariables to do it, right? Oh. Well, okay. Well, if you want me to do... I can do it as a vector if you want me to do that. No problem at all. But I don't think vector 2 takes decimals. That's the thing. Does it? Oh, it does. Okay. Alright. So, I thought, because when it said subvariables, x and y subvariables, that means like scale.x, scale.y. But maybe I was wrong about that, my bad. Alright. Introduction to while loops. Whoop whoop. You've seen that you can use functions to reuse code. In this lesson, you'll learn about loops. Loops help you repeat code. To illustrate how loops work, let's take a game board split into a grid. Our robot can move to a neighboring cells by changing a vector 2 variable named cell. It represents the current cell the robot is in. When we increase cell.x, the robot moves to the right. Note that we delay the robot's movement in the app to help you visualize how it moves. The following code would normally move the robot instantly. So, I just read all of that, and I didn't read it at the same time. Our robot can move to a neighboring cell by changing a vector 2 variable named cell. Okay. When we increase cell.x, the robot moves to the right. Okay, the subvariable. Wait. Yes. And we move it to the right twice. Note that we delay the robot's movement in the app to help you visualize how it moves. The following code would normally move the robot instantly. Ah, I see. We can move diagonally by adding a vector 2 directly. Cell plus equals vector 2, 1, 1. Yeah. You got it. The above code works for a predefined board with the size of vector 2, 3, 3, but the move to end function wouldn't work if the size of the board was different. The robot would either stop before the end or go too far. To implement a general solution for all board sizes, we can repeat the robot's movement until it gets to the end. For the code that repeats, we can use loops. Using while loops to repeat code. You can use a while loop to make the computer repeat a block of code until you meet a specific condition or decide to break from the loop. Here's how we'll use a while loop. Var number, the variable number equals 0, while number is less than 4, print number, and number increments by 1. We use the variable number to keep track of how many loops the while loop completes. Each time we go through the while loop, we add 1 to number. The while loop keeps running for as long as the condition is true. In this case, it keeps running while number is less than 4. You can see that the following code is executed 4 times in the console. Yes. So it does 0, 1, 2, 3. That's right, it always starts at 0. Yeah. Uh-huh. Yes. Love to see that. Let's apply this to our move to end function. This time we compare the number of loops to the board's width. We go through the loop until we reach the width of the board. Note that we move the robot until its position is 1 less than the board's width because we are counting tiles from 0. A board of 3x3 cells would have cell coordinates going from 0 to 2 on both the x and y axis. Yep. Func move to end while cell.x is less than the board size.x minus 1 because board size is 3, but because, like you said, we're starting with 0, you have to go by minus 1. Cell.x increments by 1. Let's do it by 3. Yeah. While loops can cause issues. Yes, they can. If you're not careful, your while loop can run infinitely. In that case, the application will freeze. Take a look at this code example. Variable number equals 0, while number is less than 10, draw square. Ooh, yeah. What would happen if the computer tried to run the code? It would draw squares infinitely until the program is terminated. Because we never increment number. When to use while loops. At first, you will not need while loops often. Even the code we show here has more efficient alternatives. Also, there's a safer kind of loop, for loops, woo! Which we'll look at in the next lesson. Yet while loops have while loops have important intermediate to advanced level uses, so you at least need to know how they exist. Know they exist and how to use them. We use while loops every time we need to loop an unknown number of times. For example, games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. Delta. That makes sense. There are good uses for while loops. Reading and processing a file like a text document line by line, processing a constant stream of data like someone recording audio with a microphone. Me. Reading code and converting it into instructions the computer understands. Various intermediate to advanced level algorithms like finding paths around a map for AI. Let's practice some while loops. As they're useful to know, it's also an excellent opportunity to practice 2D vectors. Then we'll move on to the safer for loops in the following lesson. Moving to the end of a board. Use a while loop to have our robot move from the top of the board to the bottom. Our robot has decided to stand at the top of the board. Complete the move to bottom function so the robot moves to the bottom of the board. The board size is determined by the vector2 board size. The robot's current cell is vector2, 2, 0. Make sure to use a while loop so the function works for any board size. While current cell is vector2. So current cell? Can I say cell? But we didn't define cell yet. So wait, we need to find the cell. Cell equals vector 2, 0. While cell dot y, right? Yeah, is less than, whoops, that's not less than, it's less than the vector2 board size. Oh, whoops. Wait, are you saying I'm confused because I want to say this, but pretty sure you can't have spaces, so it's just vector2 board size. What? Maybe it's just board size minus 1. Cell dot y plus equals 1. Oh, whoops, I'm sorry, vector 2, my bad. Vector 2 and int operator. Interesting. Oh, okay, board size dot y minus 1. Can I do that? Okay, thank you. Alright, let me just make sure. Yeah, vector 2, 0, and I'm saying while cell.y is less than board size.y minus 1, cell.y plus equals 1. Yeah. Alright. Very nice. I think I have enough time for one more lesson. Possibly. Or two. Oh, look at us. We're more than halfway done. Beautiful. Introduction to for loops. In the last lesson, we looked at while loops. We found they were useful if we don't know how many times we should repeat code. However, they could result in infinite loops if we're not careful. The loop below never ends because we never increment number. Variable number equals 0, while number and we said yes, this will go on forever. There's a safer and often easier kind of loop, the for loop. We'll look at it in this lesson. Unlike while loops, for loops don't run infinitely, so it's much less likely that you'll get bugs in your game. We recommend favoring for loops over while loops because of this. Let's change the code above to use a for loop instead. The loop below will change the cell 3 times. For number in range 3, Python moment, cell plus equals vector 2, 1, 1. Let's explain what's going on here. The range function. Godot has the helper function range. Calling range n creates a list of numbers from 0 to n minus 1. So calling range 3 outputs the list of numbers 0, 1, 2, and range 5 outputs 0, 1, 2, 3, 4. What list of numbers would range 6 do? Up to 5. How for loops work. In a for loop, the computer takes each value inside a list, stores it in a temporary variable, and executes the code in the loop once per value. Function run. For number in range 3, print number. Yes. In the above example, for each item in the list, Godot sets number to the item, then executes the code in the for loop. Yes. We'll explain arrays more thoroughly in the next lesson. Arrays! But notice that the number is just a temporary variable. You create it when defining the loop, and the loop takes care of changing its value. Also, you can name this variable anything you want. This code behaves the same as the previous example. For element, yeah, it doesn't matter what you put in. You say for I in blank blah blah. In both examples, we print the value of the temporary variable we created. Number in the first example and element in the second. As Godot moves through the loop, it assigns each value of the array to that variable. First, it sets the variable to 0, then 1, and then finally 2. We can break down the instructions the loop runs. You can see how a loop is a shortcut to code that otherwise gets very long. Blah, blah, blah. Yeah, because that's just too much going on. We could put whatever code we like in loops code block, including other function calls like draw rectangle, using a for loop instead of a while loop. Here's our old move to end function with which we used a while loop. Yes, we did do that. If we use a for loop instead, the code becomes a little simpler. For number in range board size.x minus 1, cell.x plus equals 1. Rather than constantly checking if the robot reached the end of the board, with the for loop, we take the board's width beforehand, then move the robot a set amount of times. The function still works the same. You can execute it below. Period. In the practices, we'll use for loops in different ways to get you used to using them. Once again, the robot has decided to stand up at the top of the board. This time, use a for loop in the move to bottom function to have it move to the bottom of the board. The board size is determined by the vector 2 variable board size. See, they forgot the variable part because there's vector 2 board size squished together. The robot's starting cell is vector 2. Okay, so we have cell equals vector 2, 2, 0. And then we say for range. Wait, for. Dang, we just talked about it. We just saw it. I'm so sorry. I'm like blanking on how to talk that out. For number in range. That's what it is. and then you put in the size of the board minus y. So it's not we're putting cell. Oh, because I guess cell already exists. I wonder if that's the case. Okay. So for number in range of the board size, board underscore size, sorry, snake case, dot y minus 1. Don't forget the colon. Then we are doing cell dot y plus equals 1. Okay. Use a for loop to remove the duplicate code in the run function. In this practice, we revisit the turtle and drawing rectangles. With our new knowledge for loops, we can condense this code to take up less space and make it easier to modify. The turtle should draw 3 squares in a horizontal line. The squares should be 100 pixels apart. Okay, with our new knowledge, we can condense this code to take up less space and make it easier to modify. The turtle should draw 3 squares in a horizontal line, and it should be 100 pixels apart. For number in range or we could say for in range, because it's 0, 1, 2. Like, you can take this. Like that? Is that what you mean? Okay, cool. Phew! Wasn't overworking my brain on that one. Alright, do I have enough time? Okay. Should I do one more? Okay, one more. Creating arrays. The range function we saw in the previous lesson outputs a list of numbers. For example, calling range 3 produces a list of numbers 0, 1, 2. Yes, we talked about this. A list of values, numbers, or otherwise has a precise name and code. We call it an array. So we can say calling the range function produces an array of numbers. We could directly write and use that array inside our for loop instead of the range function. You can run the next function step by step to see how it works. For a number in that array, as you can see, the code still works the same. Notice that when we create a for loop, we can also create a local variable to which the loop assigns one value per iteration, which is number. Above, we named it number because the array we loop over contains 3 numbers, 0, 1, and 2. But we could name it anything we'd like. If we unwrap the for loop above, we'd get the following code with the exact same behavior. The syntax of arrays. We write arrays this way in GDScript. Okay, like Python. You can start with an opening square bracket, then you write comma separated values that compose the array. Finally, you need a closing square bracket to complete the array. Here are a couple of valid arrays. Notice how you can mix values and how they don't need to follow one another. Oh wow, vector 2, 0. Wait, these all count? Because vector, I thought these were not. I guess you could put anything in it. No! That's with dictionaries, no? With arrays, I remember there was like a limitation to what value data types you could put in it. Or could you? In Python, could you mix it with string and integers? Could you? I don't think so. I think they ought to be the same data type. But I guess with Godot being variables and not having... I thought they were going to talk about variable types, but they haven't yet, so... Interesting, because these aren't integers, they're vectors, coordinates. Because arrays themselves are a value type, just like numbers or vector 2, we can assign arrays to variables to reaccess them later. That'll come in handy in the next lesson, where we'll use those variables and loops. Variable numbers 1, 2, 6, 7, variable vectors and numbers But first, let's see when you'd use an array. When you use arrays. In computer programming, we use arrays all the time. Precisely, you'll use them whenever you need to store a list of things. You always need lists of things in games. The player's party in the RPG, the items in the player's inventory, the high scores in an arcade game, the objects in the game world. All of those and many more rely on arrays. Using arrays to follow a path. Let's look at widespread use of arrays in games. Finding and following a path. In games, you need allies or monsters to find their way to their target, whether it's the player or some point of interest. To achieve that, we use pathfinding algorithms. As the name suggests, those algorithms find the path between 2 points and follow AI and allow AIs to traverse the game. Many of those algorithms use arrays of vector 2 coordinates to represent the path. Okay, take this turtle pet. It wants to follow the robot, but there are rocks in the way. How can we tell it where to walk to reach the robot with an array? Oh god. Math. Numbers. Coordinates. Path to robot. Dear Lord Jesus. Okay, so you have to calculate it. Yep. Every value in the array is a vector 2 and represents a cell the turtle needs to walk through. Together, all the values in the array represent a path we can draw. In upcoming lessons, you will see how we can use arrays to store player inventories or design attack combos. For now, let's practice creating arrays. Walking to the robot. You're gonna make me do it! The turtle wants to meet the robot, but it cannot find it on its own. Fill the turtle path array with vector 2 coordinates. Oh god. Okay, it cannot move diagonally. You know what I gotta do, man? We're gonna have to do this multiple times. Okay. I don't know how many, but let's start with this for now. 5, 3. Oh wow, that was the perfect amount of spaces. Look at me go. Beautiful. Great. Okay, in this tactical game, the player and computer can select multiple units at once. You need to call the select units function and pass it in an array of vector 2 coordinates to know which units to select. Each vector 2 in the array represents a cell with the unit. You can pass arrays and function calls as arguments. As an array is a value type the computer recognizes, you can pass the whole array as a single function argument. I'm so sorry. Ooh. A lot of that just went over my head. You can pass arrays and function calls as arguments. Oh, okay. Yeah. I see what you mean. I get it. Select all the units on the board by passing the correct array to select units function. So... Wait. Do you mean like this? Or do you want it to be like vector... I think they mean like vector 2. Is that what you mean? Okay, cool. Awesome. Great. Alright, so we covered... I forgot what lesson I started on. Was it 8? Maybe? 8? Or... I think it was 8. So we covered a pretty big amount. We did like 11 lessons then. Defining your own variables. Yep. Oh yeah. Yeah, we did all of that today. Awesome. Yay. Great. So I think that about calls it. The study session was really good. I feel like we progged a lot. I believe next video I'll probably wrap this up. And then I can finally just get into the Godot space and start playing around, sandboxing, looking at some YouTube tutorials, and start configuring. I also want to get back into that animation and do my animation practice, and also diving into pixel art, because I think the only real way to sandbox, you can definitely use assets that people have already out there, but a part of me wants to be able to actually create my own stuff and play with my own assets that I've made by my own hand. But yeah, definitely that's a lot to take on for sure, but I definitely am really appreciative towards this Godot GDScript from zero, so I can just start understanding it more. So a lot of it looks like Python, which is amazing, wonderful, perfect, and I think I can start getting the hang of it. So thank you all for watching. I will see you in the next one.